warmly welcome to Harshita Academy. This is Harshita. So today we're gonna discuss about the lesson Work and Energy about physics, CBSE, NCERT and foundation course also included here for your future goals. It will be helpful. So let's get started our video. So our lesson name is Work and Energy. So normally, we all know what do you mean by work. We simply say that reading, writing, teaching, these are some works. Work means doing something. We normally say that. But we are going to scientific meaning of work, the definition will be changed. Because in physics, we consider work as when work is done by the two factors, displacement and force. In our previous chapters, we heard about displacement and force. Force means sum of the amount of push or pull is known as force. And displacement means a distance. It's nothing but distance, but it is the shortest length travelled by an object is called displacement. So these topics we already know. So let's understand now what is the scientific meaning of work. So firstly I'm gonna write that what do you mean by work. So this work. Okay. Firstly I give some situations. A student doing hard work for study. Yeah, right. He or she are doing writing. Means that student doing hard work, means he or she writing, reading daily. So we can consider it as a work, but coming to physics or science, it not consider as work, because work include two factors, displacement and force. So it includes these two factors. Okay, right. We can take another example. An athlete was running in a competition. He doing some work, we all consider that. Coming to us also means in a physics, it considered as work because it includes two topics, displacement and force. Not only including these two factors, but it also do. Firstly, I'm gonna explain that work is done. When work is done? Work is done when the force causes displacement in the direction of force. Simple guys, so it's right that work is done when force causes displacement in the direction of force. Means what do you mean here guys, that work is done when force causes displacement in the direction of force. It means that work is done. Firstly you have to note when work is done, this force causes displacement, means this force is there. We can take a 10 Newton force. Here take an object, we take a ball. Okay, right? This 10 Newton force is applied here, and the ball, when we apply some force onto a ball, then what happened here? The ball is moved. Some displacement is causes here. So by applying this 10 Newton, it displaces up to, this is a ball first initial place, and it moves to this place. How much distance is traveled is 5 meters. Example, we take 5 meters. So by this force, there is some displacement happen here. Means by this some force, then here some displacement takes place. So what we understand here now, when a force causes displacement, there is applied here rule in the direction of force. When the force causes means it causes some displacement in the direction of force. Yeah, right. This force is applied in this direction. The displacement also causes in this direction. So you have to note down this point also. So this is very important. This point is very important. You have to note down. So now see the physical formula, means what is the formula for work. How to identify the work when there is a questions given. So let's see the what is the formula for work. So now what we know before this is we know that work is depending on two factors, that is none other than displacement and force. So we can write that one thing I have to note that work is denoted by W. So I can write here W. W equals to, means work equals to two factors. It's simple guys that force into displacement is nothing but a work. So what is our final formula? Force into displacement is said to be work. This is the formula you have to note down. It is very important. So nextly in physics what we study formula, and nextly we're going to go for unit. So let's see the what is the unit for this. What is the unit? So force into displacement here. What is the unit for force? We all know that it is Newton. And what is the unit for displacement? It is nothing but meters. So what is the Newton meter? So this Newton meter is also will be called as 1 joule. Joule, which is denoted by J. J means joule. Joule means 1 Newton meter. So here the unit is 1 joule. The unit is 1 joule. So note down that what we know that firstly work is done when force causes displacement in the direction of force, and nextly a formula of work, force into displacement, and the unit is 1 joule where 1 Newton meter. So guys, this is all about work, but normally it is what we know that about work. Work is nothing but doing something is, yeah, right, but we are going to physics, means science, it is little bit different. You can see here. So now tell me, I ask him questions that reading is a work or not? Means comparing to science. Tell me, yeah, that is not a work. We are being considered on a physics. Okay. You are walking. Walking is a work or not? Yeah, right, that's work, because some force you have to apply and some displacement is happening. So it is considered as work. So now let's see the next topic. Okay, right. So for doing work, what you need? Of course, energy. For doing some work, we require some energy. Where do the energy comes from? Our food. So for machines, it comes from electricity. So the next topic is we are discussing about the energy. Yeah, right? Let's go for energy. Okay, right? Okay. So now let's move on to the next topic, energy. So we require energy to do work. So what we call, what is the definition for energy here? We require some energy to do work. So the energy is the capacity to do work or the ability to do work. I simply say that the ability to do work. So I simply say that the definition is the ability to do work is said to be energy's definition. I mean the capacity we require to do some work. It's nothing but energy. So here now, this energy means in our daily life there is so much energies. There are so many types of energies we have seen. So some has a sound energy. I can list down that: sound energy, light energy, mechanical energy, kinetic energy. So kinetic energy and mechanical energy we can discuss here now. So many types of energies are there. So now we can talk about mechanical energy. So mechanical energy. Right, okay, right. Mechanical energy. When we talk about this mechanical energy, it means simple that I mean, what is the definition for energy is the energy possessed by an object. I'm writing now here. So the energy possessed by an object by virtue of its configuration and configuration, rest, state of rest and state of motion. So this is the definition for mechanical energy. So the energy possessed by an object by virtue of its configuration, rest and motion, or state of rest or state of motion. Means don't fear about this definition. I will clearly explain that. So firstly, try to understand what do you mean by mechanical energy. So here the energy, right? Here the energy possessed means carried by an object by virtue. Means virtue means you cannot take a meaning due to. Due to. You can take a meaning this due to. Okay. By virtue of means it's okay, right? You can take the meaning by virtue of means due to. It's nothing but due to. By due to its configuration. What do you mean by configuration? It means okay, right, I'm gonna use this blue pen. Okay, right. What do you mean by configuration means it's nothing but shape or size. Shape or size. We call it as configuration. Yeah, right. We're going to rest and motion. You've already studied about in your previous classes that in motion lesson. Yeah, right. So motion means change its position with respect to time, where there is no change in position with respect to time. Rest means okay, right. Rest means there is no change in position with respect to time. Motion means there is some change in position with respect to time. So here rest and motion and configuration means the energy possessed by an object due to its means that energy is required by its shape or size means configuration, rest and motion. Yeah, right. Alright, this is about mechanical energy. Whereas this mechanical energy is divided into two types. They are nothing but potential energy and kinetic energy. So, what are the both? Kinetic energy. These is divided into two types. Kinetic energy and potential energy. So, this mechanical energy is divided into two types. Those are kinetic energy, potential energy. So, now let's understand what is kinetic energy. Here you're right, there is three factors which define mechanical energy, right? Configuration, rest and motion. Where here now, where kinetic energy which is due to motion, there's motion. Means the energy possessed by an object, I am saying definition now, the energy possessed by an object by virtue of its or due to motion or by virtue of its state of motion is said to be kinetic energy. Means this factor, which factor is required here? Motion. The energy possessed by an object by virtue of its motion or due to motion is said to be kinetic energy. By going to potential energy, these two factors are divided: configuration and rest. These two factors are required here. So potential energy, it's the energy possessed by an object by virtue of its state of configuration or rest. Configuration or rest. Okay, right? Configuration or rest. So, kinetic energy, potential energy. So, this kinetic energy I will write is K E. But you don't write this. Where it will be repeated, you can write like this because it's short form. Yeah, potential energy. Potential energy, which is then denoted with, for writing a formula, it is denoted with U. Well, potential energy. For writing formula. So now I can tell you what is the formula for kinetic energy. So let's get how to write a kinetic energy formula. So let's denote it. Before that, I'm going to say you what is the formula for potential energy. So let it write now here. So potential energy, which is U. Okay, we writing U. So potential energy here. Before that, I'm going to say you that mechanical energy is there here. This mechanical energy is equals to potential energy plus kinetic energy. Kinetic energy plus potential energy. Okay. It's a something formula I will write. It's not necessary, but you can also remember that. Okay, potential energy. We know what is the formula for work. Work equals to force into displacement. So this where I can say you something that energy. This energy is there. This energy is directly proportional to work. So you can consider work as energy here now. What is important point? Energy is directly proportional to work. So here right now, work equals to force into displacement. If I consider this as work, which for potential energy, this which is denoted by U, then I am writing U equals to what it right now, force into displacement. Actually, what is the formula is mgh. How it is happened? Okay, right? U equals to mgh. Potential equals to M means mass into acceleration due to gravity, small g, height. In your previous chapters you had about what is acceleration due to gravity. When during free fall it requires some acceleration. So that acceleration is a unique value, that is 9.8 meter per second. So we know that formula, we know that value 9.8 meter per second. So actually mass means some matter. Mass is nothing but a matter present in it. So height. Why height is happen here? Why height is included here? Okay, right. I take an example that if a block, if I take a marker, this marker, it is present at my hand. Firstly, at my hand, I can lift it to my some space. So this distance, this in between this, there is some distance between mark and my hand, means a floor. If you take this is a floor, this is an object. I can lift it from rest. Firstly, it present it at rest. So this potential energy, one thing I have to tell you that this potential energy will convert into a kinetic energy where it requires. Okay, yeah, right. So I taking this, it presented rest, it's presented potential energy. If I lift it, it gains some energy and it converted to kinetic energy because it's moving. So what is the distance here, which is the distance here between this floor and this marker, is considered as height here. It considered as height here. So what is the final formula is U equals to mgh, means potential energy equals to mass into acceleration due to gravity into height. So what is the unit for this? Energy unit is also joule. 1 joule equals to 1 Newton meter. So here this unit is also joule. So 1 joule. Unit also we had. So this is all about potential energy. So now let's discuss about kinetic energy. So let's get started. So now let's discuss about what is the formula and how we derive the formula of kinetic energy. So kinetic energy. What we know that kinetic means energy is directly proportional to work here. So here kinetic energy is also it is also energy. So energy is directly proportional to work. So kinetic energy is directly proportional to work. So now we consider the work formula. So let's write the work formula. Work equals to force into displacement. We all know that. Now let's you know that in motion lesson we learned some kinetic equations. So now let's write or revise it because it's required here now. So kinetic energy, kinetic equations. In those equations we take one equation. What is that? Is v square minus u square equals to 2as. V square minus u square equals to 2as. We can take this equation where here u means the initial velocity or initial thing is there. We can consider as that 0. So 0 square is also 0. So minus sign also gone. So what we require now? V square equals to 2as. So 2as. So what we know now, here we require displacement. So this s is gone here. S equals to 2a by v square. And what we know, this is the what we need now. So we are going to force. Force, what we know about force? Force equals to mass into acceleration. So force equals to ma, mass into acceleration. So now let's put it there. So by taking here work as a direct kinetic energy. So I am taking kinetic energy here equals to force into displacement. So what force equals to ma? Ma into displacement equals to 2a by v square. Yeah, right? Something had to be changed here. So s equals to v square by 2a. Okay, right? V square by 2a. It will be something change that. Because s equals to v square by 2a. So v square by 2a. V square by 2a. Alright. Now let's cancel those things which are a cancelled. What we m into v square, mv square, half mv square. So kinetic energy equals to m into v, mv square. So half is there here, 1 by 2 half. So half mv square. What is the final formula? Half mv square. Kinetic energy equals to half mv square. So this is our final formula where kinetic energy equals to half mv square, mass and velocity square. So this is our formula where we can divide into by these terms, by these two terms, this term and this term. These two terms, by these two terms we can derive this formula. So this is all about kinetic energy. The unit, very important, which is the unit for energy is joule, 1 joule, which is denoted by J, which is equals to 1 Newton meter. So alright, next we are gonna go for law of conservation of energy, which is one of the important topic. Law of conservation of energy. I can simply explain that what do you mean by law of conservation of energy is that, remember this point guys, energy is neither created nor be destroyed. Energy neither be created nor be destroyed. It only transform from one form to another form. It's not neither be created nor be destroyed. It is called about law of conservation of energy is nothing but the energy is not be created nor destroyed. It only transforms from one form to another form. If we take as example as potential energy, which is potential energy stored An object which is by virtue of its rest, it is stored by form of potential energy, where it gains some energy to conform to kinetic energy. Kinetic energy. So this is an example for law of conservation of energy, that are not a law of conservation. The energy can transform from one form to another form, but it not be destroyed, not be created. Yeah, right. So now let's move on to the next topic. Very important topic: power. It's another physical quantity, power. So this power. Power means what we know about power. I simply say that writing that rate at which work is done or energy is transferred. So what do you know that work is power is power? Okay, rate at which work is done or energy is transferred. So rate at which work is done or energy is transferred. Some energy is required for doing some work. So this energy, here I want to say rate at which work is done. Rate at which work is done and energy is transformed, or energy is transformed is considered as work. Means it's simply say that rate of doing work. Rate of doing work is said to be power. So this power formula is, where here power is inversely. This formula, power is directly proportional to work, where and it directly proportional to energy also, because work is directly proportional to energy and inversely proportional to time. So power inversely proportional to time. So what is our final formula? P equals to, this power equals to W by T. And or we can also say that where work is also, we know that before, work is also directly proportional to energy. So by this, power equals to energy by time also. These two formulas we can use, and here power equals to work means work by time and energy by time. These are the two formulas. And what is the unit here? We have come to unit work. Wow, so we can try to write the unit, that work unit is joule by time unit is second. So joule per second. We can call joule per second as 1 watt. So alright, 1 joule per second equals to 1 watt. So what is the final unit is 1 watt. This is the unit. So this is all about work and energy chapter, guys. So all core concepts are covered in this chapter, where about work and energy and power also. And also learn about law of conservation of energy also. Units, their formulas and definitions you have to note down in a book. It is very important, and revise this concept, because these are very important, and which these all covered in CBSE NCERT foundation course also, because foundation course also included here for your future goals. This lesson is also very useful. So for more videos, subscribe to Hashit Academy. So bye guys, in the next video.